So H2 cloud. If anyone around here, anyone here can help, maybe share the opinion. What does H2 cloud mean in a short word? Anyone there? H2 cloud. In your opinion, it's nothing wrong. What's it all about? What's the meaning of H2 cloud?
It's from device to server.
Yeah, that's good. That's good style. Yeah, that's right. I mean, I can't say it's right or wrong because, as I say, it's people take it in, let's say, different. This is, let's say, my own version. I hope it's aligned with you. In case of not, then yeah, both answers are correct. So before we go further, just a short intro of myself. My name is Sarun Kub. Some people who know me well, this is not my real name. Because my real name is much longer and they cannot pronounce it, so I just cut it short. So call me Sarun, that's fine. So I'm from the company called Robustel. I think some of you maybe heard about it, but some of you use our product already. So I have been with Robustel since 2017. Yeah. Some of you maybe know me from the even past life. I used to work for another supplier before. So today presentation will consist of it's 5 bullet points here, but actually it's only 2 things. The first thing is like, okay, the H2 cloud concept. Then the last, let's say the second part is just like example, how we actually develop or how we actually implement H2 cloud concept into the real applications. Only 2 things, simple as it is. Before we start, any questions so far? No questions. Good. Before we're talking about H2 Cloud, I like history. So if we trace, let's say, if we look back like 10 years ago, early 2000s, before we, let's say, really the cellular or the wireless communication become the norm for the, let's say, industrial applications. Usually, it consists of, let's say, 3 parts, right? If you have a question, don't wait to the end, okay? It consists of 3 parts. The first part is, sorry, it's supposed to be this one first. It consists of 3 parts. First of all, you have the, let's say, the local or remote network, right? It can be anything. It could be the substation. It could be any asset that located on the field, right? You have this kind of the asset. You have the device, and then you connect them together from the maybe communication like RS-222, 422.485, serial communications. Maybe it could be Ethernet. And then you combine this kind of communication together into the RTU, remote terminal unit, PLC, or maybe HMI, and then you connect it with the, let's say, local LAN. So you have the remote, let's say, remote network here and there. Okay, it depends. It could be 1 site, 2 sites, 100,000, and so on. So that's the first part. And then the second part is, well, it's a center. We call it center or the local network. Right, so you imagine when you have like a local, let's say 100 of the local site that you want to access and control. You have the center that you're sitting here and you want to access, okay, I want to control the device here, I want to monitor the device there. So you have the, let's say, center that handle all the, let's say, all the communication here between local network and, between local center and the remote network. So as you can see, in the past, I would say, in the past, the gateway is act mainly, it's just like for data communication. So that means you have the data here, you want to transmit here, or you have the data here that you want to transfer to here to the local network. So the gateway, or the piece of hardware here, it just like act as a data communication unit. So this is how it works. 10 years ago, even until now, many of you still use this as it is, right? So this is a role of the gateway. So it acts as a data communication, firewall, and etc. And for the remote network, most of the data processing and the protocol conversion is done locally, like, right? So maybe you have a RS-232, you want to connect to the TCP, so you have a device server here, or you have like a PLC and connect with the multiple devices with the different protocol. So most of the data processing is done locally, and it converts to the IP and you connect it to the data centers. So that's a local network. Now, it comes to the problems. The first problem is, well, when you have a gateway here, you put a SIM card, right? You have the local network. You have the local network here. You have the Ethernet switch, and then you connect to the gateway like this, right? You have the serial communication connect to the gateway. You put a SIM card inside. In the past, you have several problems. The first problem is it IP address is a public or private one, right? The first issue you always have. So some of you who are familiar with it, okay, this is easy, but some of you who are not familiar with this, public and private IP, it means like, well, when you have a SIM card, right, you connect to the gateway and the mobile network operator assign the IP address to the device. If it's private, it means the communication from here can go to the center. It's no problem because the communication starts from here. But if you have the local network here and you want to access the remote network, if the IP address of the gateway is a private, it's impossible because it's a private IP. You need a public IP to do that. Or you must let the remote network initiate the communication. Initiate communication from here to here. When the socket is open, then you can communicate it. So you can communicate things. So the first problem, public and private IP. In the past, you can also acquire public IP from the mobile operator, but of course it costs money. And as you know, we don't want to pay for anything. The second question, the second issue, is it static or dynamic IP address? What does it mean? So when you put the SIM card inside, you get the IP address. Okay, luckily it's a public. However, the IP address that you get here, it is dynamic. So that means if you connect twice, the IP address is different. That means if even you're sitting here and you try to reach this network, if you don't know what is the current IP address of this one, you cannot communicate. You cannot communicate to the remote networks. So that's another issue. Data security. In the past, we have the issue, okay, what happens if someone tap the information and so on? How do we know this is a legit person who tried to connect to the network, and so on and so on. And of course, the things doesn't work just sometimes issue happen. Maybe it's lost connection, maybe some problem with the end device, maybe the problem of the gateway itself, so how to do the remote management. So this is the overall pictures of the problem or the issue that we have since early 2000, even nowadays. Yeah. So let's move a little bit. Actually, in the past, we also have let's say, the solution for it. What most of the suppliers have been doing is, okay, this is a problem about the public-private IP. What they are doing is simply like this. Oops. They put the proxy server here. Proxy server, it could be like some physical server, or you can just put it as a software into the different location. What the proxy server does is, okay, the proxy server has a public IP, and it acts as a, let's say, the interim between remote networks. You maybe have like this 100 of them, 1, 2, 3, 4, 5, and everything is connected to the proxy server, and the proxy server has a public IP. So the communication will go between remote network and the local network via proxy server. So this is what the supplier, or what I can't say supplier because this proxy server can be done independently. So that means you can just, okay, set the proxy server here, and it doesn't matter is it a public IP, private IP, or static or dynamic IP address at the gateway. The communication can go through the proxy server. So the proxy server will act as a, let's say, the contact window for the let's say for the communication. This is what the solution, which is have been implemented, I would say, in late 2009, 2010, that many suppliers try to implement this kind of proxy server. Most likely it's just a software. So this proxy server, sometimes they also have their, let's say, VPN connections as well. So it okay to overcome the problem of the data security. They also have the, let's say, sometimes it also embedded with the VPN as well. So it acts as a VPN server. So that means the local network can communicate to the remote network via VPN, via proxy server. And sometimes, I mean, it's also possible as well to use the VPN. But the problem is, okay, this one you also need to have a big server that can handle many VPN sessions. But as you can see here, even with proxy server or without proxy server, the main role of the gateway here is simply data communications. And this is kind of history, but even nowadays, many use cases still based on this communication scheme, even nowadays. So, what has happened so far? Now the word cloud solution come in. I think when was the first time you heard about cloud solution or cloud server? When was the first time? How many years ago? 5? Around about 5 years ago. Anyone give me a bigger number? You get 5. So, okay, 5 years ago, now people start to hear about the cloud solution, and it was like, oh, cloud is somewhere over there is a solution by God. Actually, as everyone knows, cloud is simply the someone else's computers. This is the fact, right? It's just someone else's computers. So it's hosted by Microsoft, Amazon. It could be by you. You can have your own cloud as well. So, however, as you can see that, so many big companies, let's say many platform, they offer the platform as a service. It could be Microsoft Azure, right? Microsoft Azure, AWS from Amazon, Cumulocity, this one from the software arcade, ThingsWorks, or even private base and etc. They also have the cloud or the service or the cloud computing service or platform as a service. So this happened 5 years ago because, well, they say that, okay, why you need to handle all the assets by yourself? You can use the platform that offered by those companies to handle the computing part, to do the visualization, and you can install your package over there. So as you can see here, there's a two development in this kind of application. The first, let's say the first development at the application side is, well, as I say, in the past, the gateway is act only at the data communication between sender and the remote side. However, when the time passed by, people start kind of, okay, well, we need something to be visualized, because the data communication is like, well, you just connect, open the socket and see whether that data is coming. When you have a lot of assets to manage and control, you also need to visualize it. So, well, you can do it via SCADA, that's possible, but with nowadays you have more, let's say, option compared to the past. So, well, they want, at the application side here, they want to visualize it, they want to control it, they want to see how these end devices are doing, right? And also emerging of the cloud 5 years ago, they say, you know what, we have platform as a service that can handle this kind of let's say, the platform to help with the visualization, to help with the developing and so on. And well, for the application side also, well, I want flexibilities and scalability. So why should I use only the software from you? Why can't I just use the software from Microsoft, and I use hardware from you, and I use the sensor from you, and something like that. I want flexibilities. I want freedom of choice. And of course, in many big solutions, or in the big a lot with the application, sometimes they also need a tailor-made solution. So well, I want to be like this and this and this and this. So that's why the platform like Azure or AWS, they give this kind of flexibility and a tailor-made solution. So this is a requirement that has been changed approximately 5 years ago until now, so that we can see more of this becoming, let's say the demand is higher for the application side. However, at the device side as well, there's a lot of change. First is variety of use case. In the past, we don't have so many use cases, right? So the remote side usually is some kind of sensor, maybe the controller that based on serial communication. Right now, everything you can connect via maybe LoRa, maybe some sensor, there are humidity, CO2, and so on. So there's more and more use case coming every day. So there are more use case at the remote side, you have more node. And as we can see, there's a less high-end server. In the past, you have PLC and you connect like 20 devices around it. And right now, the application side, they are more or less like split from the one big server and many devices into it. And right now, it's kind of split that, okay, this is for the non-vital, this is for the vital application, and this is something that, okay, I don't care. And most of them, they want to say, I don't want to have a centralized communication anymore. Less individual node can communicate directly to the centers, something like this. So we can see this kind of the application that, okay, it's less centralized, but more, let's say, it's more simple, let's say this way, at the end node. It's more simple. And of course, when we have more device at the end node or the remote network, the thing is, many of the tasks can be done locally because you don't need to send data to the cloud, right? All the way, do the computing there and you send the control back. Many of the tasks can be done locally as well. So the customer also say, well, can this kind of a simple task, can we do the edge computing? So this means that some other operation can be done locally to compute, to solve the simple problem, and it just control to the end device. So they don't need to send all the data back to the centers, or maybe they just combine the data into the certain format and send it to the center to save the bandwidth or reduce the data amount of the data. So this is what happened at the device side. So two things that happening. So as you can see here, this gateway 15 years ago, which act as a data communication, pure data communication. Nowadays, because of the demand or the demand for the application side and the device side is changing. So it changed that, okay, well, data communication or bridging is just not enough. It needs to act as a, let's say, interim or the decoupling between these two parts, application side and the remote network side. The edge to cloud consists of three things. Let's see. These are, from our understanding of the edge to cloud framework, it consists of three things. The first one, southbound application. What does it mean? If you go back to here, you have a gateway, right? And you have a device that connects into it at the local side. And you have the people who sit at the local network or the control center somewhere, right? And the gateway is in between. So the southbound application is the application that connect between gateway to the, let's say, local device. It could be sensors. It could be PLC or etc. This is like example. Like for example, I think in France we are kind of like Modbus, isn't it? Yes. Yes. We like Modbus, DNP, for example. But for the building automations, OPC UA, yes, German love this one. I don't know why, but yes. EOH, I think, is a company based in Grenoble as well for the sensors, right? Also Siemens SS7, for example. M-Bus, for example, if you deal with the water metering or the water metering and so on. So this kind of a device that connect to the gateway. So we call that, okay, southbound application is an interface between the gateway and the sensor or whatsoever is it that you connect into it from the southbound side. And then we have northbound side. The northbound side is an application that connect between gateway and the platform upward. It could be, well, Microsoft Azure, AWS, IBM Bluemix, Sparkplux, Cumulocities, even Robustel. We also have something called RDMS as a tailor-made solutions. And for the people who say, you know what, I don't want to use this guy because it costs money, I have my own application, which is based on MQTT, freedom of choice, something like this. So this is called northbound applications. Southbound device to the end device, from the gateway to the end device, and a northbound from the gateway to the cloud platform or the server. As I say, that the cloud is simply someone else's computers. And the broker is an application inside the gateway that act as a, let's say, the coupling between southbound and the northbound part. So this is what we see from the edge to cloud. Consists of three key elements: southbound, northbound, and the broker applications. That's it. The next slide, I will show you an example. I would say what would we do in the southbound and the northbound side. Regardless of the supplier or other brand that you're using, I think the concept is the same. For example, the other supplier, I'm quite sure they also have similar concept as well. I mean, but maybe they don't call it southbound or the northbound, but the concept I think is the same. So the next slide, I will show you the example how what we do in the how to make the communication between end device to the cloud work. By using the concept of the northbound, southbound, and the broker application. Okay. Okay. Examples that I would like to show you. As I mentioned, the edge to cloud consists of three things: southbound, northbound, and broker. So in this case, the example with the southbound side is a Modbus RTU and Modbus TCP. So that means the gateway connect to the sensor, let's say this way, based on Modbus RTU and TCP. So I mean, this is I just copied from our screenshot. So however, as I mentioned, for the third party equipment, it could look different, but I think the concept is the same. So in this one, I show you the example of the southbound application. For example, inside the gateway, right? You have the southbound application based on Modbus, of course. For whomever who familiar with the Modbus communication, you need to set slave ID, correct? Right? You need to set function port. You need to set what else? Anyone could help me? Address, right? Yeah, what? Yeah. And if it's Modbus RTU based on serial communication, you need to set the baud rate and etc. as well. So this is an example of how to do this in the southbound application, and yeah, and so on. So this is an example at the southbound application part. Now it comes to the broker part. So the broker part, as I mentioned, the broker is easy because the broker application is simply the coupling between the southbound to the northbound. So you need to set where you want to use the memory to save the data, because in sometimes the communication is lost. How do you store the data? So you need to set the location, what kind of the brokers, and now, the northbound part. The northbound, it can be anything, right? But this one I use Microsoft Azure as an example. The reason I use Microsoft Azure is because it's the most easier platform to configure. Because I tried AWS, I couldn't make it work. So for Microsoft Azure, anyone here use Microsoft Azure for the northbound applications you use? No one else? Two. The rest, what are you using? Okay, I have homework. Today, you go back home, you go to the Microsoft IoT and you subscribe one. It's free of charge. It's free of charge. If you don't know how to configure, you go to Robustel website and we have the document for that, okay? Next year, if EBDS holds this event again, I will ask you how many of you did that. It's free of charge. So, let's take this presentation as an inspiration, because it took me half an hour to make this thing work. If it takes me half an hour, for you it means 5 minutes. So that's a challenge. Now, at the Microsoft, as I told you, go to the Microsoft website. You subscribe one. You subscribe. It's free of charge for. I think it's free of charge for 1 month or something. I'm not sure. Yeah, 1 month. So you just choose the IoT project and so on, and you just walk. If you don't know how to do it, you can go to our website. You have a walkthrough for it. So it's kind of it's a cloud platform. You just need to configure, create a project, the IoT hub, and so on. So it's quite straightforward. You create your project and you generate a key. You put this key back to the gateway, and the gateway starts to connect to the northbound applications. In this application, as I mentioned, the southbound part uses the Modbus communication, and this one is example. It's an example of the data that's sent from the sensor. In this case, I use the temperature and humidity sensors. So what the gateway does is it gets the data via Modbus RTU, converted, and it sends it via the gateway to the Microsoft Azure. This is one from the Microsoft Azure, and this is like in the JSON format. So you can see it here. Oh, you can't. It's too small. However, you have a homework anyway. So I tell you, so you can see here the information, the data. This one is the temperatures. This one is the humidities based on the JSON format. So this one took me only half an hour just to get the data from the sensor to the Microsoft Azure. Simple as it is. However, this is just an example of how easy to set it up to do some simple demo and so on. So for the real applications, I have a customer actually based in UK. I forgot the name. I think it's OIO2Go. What they are doing is, they're doing just like this. They are doing it just like this. What they are doing is they have a platform that they go to the customer and say, well, they go to the customer and say, okay, do you have the asset like substation or whatsoever? Doesn't matter. And they use the sensor and then connect to the gateway. Mostly we are Modbus RTU, Modbus TCP, and then the Modbus TCP is communicated to their own cloud platform based on MQTT. So this is actually this one is come from the real application from their side. Amazing, huh? From this to this. But okay, this one you need quite some time for that, yeah? But actually this is the same concept. They did exactly the same, what I did. So basically they through the gateway, they put the sensor, transmit Modbus TCP, and they use their own platform, which is based on MQTT. So they get the data like, okay, GPS, they use this kind of a communication string and put the cloud and everything and generate a report. So this is a real live application from the edge to cloud. Easy, isn't it? So this summer, you have the new projects. This could be your backyard, and you just get a sensor from one of those guys, get some of the gateway, and you subscribe to Microsoft Azure. It costs you nothing, and you can have some small project like this. If you're getting stuck, no worry, don't call me, call EBDS. They will help you to get it work. Or okay, if you say, okay, is it too complicated? I mean, as a Robustel, we have like a platform as well, but not look exactly like this. But our platform is meant to be to monitor the gateway itself. But we also have the application that help to control the I/O and help to control help to transmit the serial data as well, or any kind of idea that you may have. Talk to EBDS. Or talk to me, but if you want to talk in French, talk to EBDS. So that's all. That's all from my part. So thank you so much. Any questions?